Hello everyone, welcome to week 6, part 5. Searching algorithms. To search is to locate an item in a list of information. In order to do that, there are two algorithms that we can use and we can examine. They are the linear search and the binary search. Linear search, also called the sequential search. So with the linear search starting at the first element, this algorithm sequentially steps through an array, examining each element until it locates the value it is searching for. With a binary search, it requires an array elements to be in order. So first you divide the array into three sections: middle elements, element on one side of the middle element, and elements on the other side of the middle element. And the second part of the binary search is if the middle element is the correct value, then you're done. Otherwise, you go to step 1 using only the half of the array that may contain the correct value. Then the third step is you continue steps 1 and 2 until either the value is found or there are no elements to examine. Let's look at some examples. Linear search, let's say you have an array num list contains the list you see on the slide. So it's a list containing numbers 17, 23, 5, 11, 2, 29, and 3. So searching for the value 11, linear search will examine 17, 23, 5, and 11. Searching for the value 7, linear search will examine 17, 23, 5, 11, 2, 29, and 3. The array numList2 contains the second list. So the second list, which is a binary search example, searching for the value 11, binary search examines 11s and it will stops. Searching for the value 7, binary search examine 11, 3, 5, and stops. Linear search algorithm. Set found to false, and then you set the position to -1, and then you set index to 0. Then you check while index is less than numbers of elements and found is false. If list index is equal to search value, found is true, set position to index or index to position, end f, and then add 1 to index. You end your loop and then you return your position. With the binary search algorithm, you set the first index to 0, set the last index to the last subscript in the array, then you set found to false, then set position to 1, then you loop. You use while loop. While found is not true and first is less than or equal to last, you set the middle to the subscript halfway between array first and array last. If array middle equals to the desired value, you set found to true and position to middle. Also, if the array middle is greater than the desired value, you set last to middle -1. Else, you set first to middle +1. You end your if, you exit your loop, and you return the position. So this is a very good example of a linear search function. And this is an example of a binary search function. Advantages and disadvantages of linear and binary search. For linear search, trade-offs. The benefits are easy algorithm to understand and array can be in any order. The disadvantages of the linear search is very inefficient or slow. For array and if n element examined, it will examine n over 2 elements and average. For value in array, n elements for value not in array. Binary search trade-offs, the benefits is much more efficient than linear search. So for example, for an array of n elements, it performs a most log 2n comparison. The disadvantage is it requires that array elements be sorted.